Okay, so example 3 in the packet said to find the points where the horizontal and vertical tangent lines occur. And so they gave us the polar equation r equals 2 times 1 minus cos theta. And they said this is on 0 to pi. So what do we need to do first?
Set it equal to 0.
Before we set it equal to 0. Yeah, we need to know what the x, we're kind of like writing it as a parametric, right? So we need the x part of the equation, we need the y part of the equation so that we can find the derivatives and do the dy dx. So x is going to be r times cos, and y is r times sine, and so the top is 2 cos theta minus 2 cos squared theta. This one is 2 sine theta minus 2 cos theta sine theta. All right, and then we're going to go ahead and do dy dx. So the derivative of y would be what? Two cos theta minus. Do you guys like to leave the 2 and then do parentheses and do the product rule, or do you use the 2 as part of the product rule when you do it? You like the 2 with it? Okay. So we'll say the first is going to be 2 times cos times the derivative of the second, cos, plus the second times the derivative of negative 2 cos theta, 2 sine theta. Okay? And then the derivative of x would be okay. And then for this part, we have to be careful that we're thinking of this as negative 2 times cos squared, so we correctly do that chain rule. So what would we have? Perfect. So this is us doing the outside. The 2 multiplies down to the front, we get negative 4, and then it leaves an exponent of 1 behind. So if you see this on my answer key, it's because I'm doing the chain rule and I'm keeping track of what I did. Multiplied by the derivative of the inside, which is negative sine. Okay, now for us, that's us finding the derivative. Of course, we can make that a little bit more clean looking, but when we do the next part where it says find the horizontal and the vertical tangent lines, what do we do with this to find those parts? Yeah, set the top or the bottom equal to 0. Okay, so I'm going to go ahead and write this a little bit more nice. So 2 cos theta minus 2 cos squared plus 2 sine squared negative 2 sine minus, nope, plus 4 cos sine. Okay, so to check for a horizontal tangent line, what are we going to do? Yeah, take the top and set the top equal to 0. Now this problem is quite a bit different from example 2. Example 2 had some equations that were relatively easy to solve. This one's a lot more like complex, right? Because we've got cosquareds and cos and sine squareds, and we can't like take out a GCF, okay? So our best, what did I miss? Oh, 2 sine squared. Sorry, thank you. So our best option here is to replace the sine squared with a cos squared somehow so that we have everything in terms of cos. So if I want to take out the sine squared, how could I change it into cos squared? You're close. It's not, we're not going to do power reducing. We don't care if it's squared. It's 1 minus cos squared. So it's one of the Pythagorean identities that's on your blue sheet. Okay? So I'm going to be taking this and I'm going to replace it with 1 minus cos squared. So keep this the same. And then I'm replacing with 1 minus cos squared. And now I can get rid of the parentheses by distributing that 2. I know you don't have a ton of room in that sheet, so if you want to shorthand some of this or, you know, do 2 steps together, that's okay. All right, so at this point, we could say we have -4 cos squared, right? Now, we are eventually going to factor this problem, and I typically like my squared term to be positive. So I'm going to go ahead and add these to the right side of the equation to make that have a positive coefficient, okay? So I'm going to say 0 equals, I'm taking these and adding them over, so I have 4 cos squared.
Can you get rid of the 2 so you have to keep writing that? Or just divide the whole thing on both sides?
Oh, divide the whole thing by 2?
Yeah.
I'm going to go ahead and write it this way, just since I already started, but yes, you can get rid of the 2. Okay, so if you want to do that as this step so you don't have to keep writing that, that's fine. I'm going to minus the 2 cos over and minus the 2 over. And then Isaiah noticed it before I did that we have that extra 2 in there, so we can go ahead and just divide out a 2. Okay, so to finish solving this, we need to factor. And this is doing it by hand, right? Like if you needed to do this in a calculator, if this was a calculator active FRQ, you could go ahead and you could graph this, find where the graphs intersected, have your solutions real quick. Okay, but they just wouldn't be exact. Okay. So what type of factoring is this? Slide divide. If you had me as a teacher earlier, then you would have said slide divide. Did you guys learn slide divide in Honeycuts? No? So it might be like, you guys might have learned it as like guess and check kind of. So you'd say this is like 2 cos, and that's cos. That's how it multiplies to be 2 cos squared. And then these 2 would have to multiply to be -1 somehow. And then you kind of guess and check. That might be how you did it? Maybe? Okay. So in my classes, I told my students we need to do 2 times -1 is -2. So we're finding 2 numbers that multiply to be -2, but add to be -1. And what I'm going to do is I'm going to write this off to the side in kind of like normal algebra, and then I'll go ahead and do it in terms of cos over here. So this is kind of like we had 2x squared minus x minus 1. Like this is the problem that we're doing. And if we look for 2 numbers that multiply to -2 but add to -1, those 2 numbers would be -2 and +1, right? So it's kind of like we have x minus 2 and x plus 1 in the parentheses. And then since this is a slide divide problem, that means we need to divide by the coefficient of 2. And so the first parenthesis is x minus 1. And in the second parenthesis, we do bottoms up, and we get 2x plus 1. So over here, this is 2 cos plus 1, this is cos minus 1. So this is how I taught my students to do it. I'm not sure how your teacher did, but you could have done guess and check and just plug numbers in until it worked. You just would have had to figure out your signs. Okay. So we have two sets of solutions, right? We have that cos equals -1/2, and we have cos equals +1. So cos theta equals -1/2, cos theta equals 1. And they told us in the problem that we're looking at the interval from 0 to 2 pi. So we know that we're thinking about on the unit circle where there's an x-coordinate of -1/2. You're thinking sine, maybe. So think left, where would we go left 1/2? 2 pi thirds and 4 pi thirds. Okay. And then where is cos +1? Yeah, 0 and 2 pi. So we have to use both 0 and 2 pi because the original problem had a bracket around both. And so that's why we're using both, even though it's one spot. Okay, so those are the possibilities of where there could be a horizontal tangent, but we're not sure yet because we have to check for the vertical tangents and see if any of the vertical tangents have these points in common, in which case there wouldn't be a tangent line, there would be a sharp corner or a cusp, okay? So we have to do that process again. Wasn't that so fun though? The other one, we just did the hard one. The other one is much easier to solve. So now we're gonna go ahead and look for the points where there could be vertical tangents. And so how do we solve for vertical tangents? Yeah, take the denominator, make the denominator equal 0 because that's where we would have an undefined slope. So -2 sine theta plus 4 cos theta sine theta equals 0. This is also a factoring problem, it's just a much nicer one. Yeah, we could take out a 2 and we could take out a sign. And I'm going to go ahead and take out the negative since it's in the front. So I'm going to take out -2 sine. And then what would be left over? 1 minus 2 cos theta. Okay. So this one would be sine theta equals 0. This one would be cos theta equals 1/2, right? Because it'd be -1 divided by -2. Okay. So sine equals 0 at 0 and pi and 2 pi, right? And then cos equals +1/2. Pi thirds and 5 pi thirds. Good. Okay. So if we look at this, we can't use 0, we can't use 2 pi because those were for both. And anytime it makes the top equal 0 and the bottom equal 0 at the same time, it actually means there's a sharp corner, not a tangent line. Okay, so we're not going to use those. At this point, we are done with the hard stuff. Now we just have to go ahead and plug these points in. So we know the theta portion of the point r theta. We just have to find the r portion, okay? So I'm going to go back up to these. And so I'm going to consider my equation, which was r equals 2 times 1 minus cos theta, or you could just say r equals 2 minus 2 cos theta. And I'm going to go ahead and use these equations. R equals 2 minus 2 cos of 2 pi thirds, and r equals 2 minus 2 cos of 4 pi thirds. So this is 2 minus 2 times -1/2. So that'd be 2 plus 1, which is 3. And then that's the same thing because they both equaled -1/2. So that means that our points where we have horizontal tangents would be 3 2 pi thirds and 3 4 pi thirds. That's where the horizontal tangents show up. And then for the vertical tangents, we're going to have to do 3 different points. So we're going to have r equals 2 minus 2 cos pi, r equals 2 minus 2 cos pi thirds, r equals 2 minus 2 cos 5 pi thirds. So this is 2 minus 2 times -1, or 2 minus 2 times +1/2, and then this one's the same. So the points where we have vertical tangents would be 4 pi, 1 pi thirds, and 1 5 pi thirds. Whew. All right, how you guys feeling about that one? Yeah, I think the process is pretty okay. The worst part, in my opinion, is this part right here, where not only is it in terms of the right trig function, you got to fix that, and then you have to remember how to factor. So I think this part of it. Now this is kind of like, if you flip your worksheet over to the back, the top problem. I believe it's the top problem. Or maybe it's one of the problems on the front. I just did one of these on the answer key. So there is one like this where it has this like factor, and to do the factoring you have to switch it into the other one. There is this portion. You do have to do that on the worksheet at some point. Okay? All right.